Bismillahirrahmanirrahim. Assalamu alaikum. Welcome to my YouTube channel. Today we are going to start our course Electronics 2. Before starting our course Electronics 2, first of all I am going to give you a overview of BJT. BJT. BJT means bipolar junction transistor. Bipolar means there is the flow of current due to the minority carriers as well as majority carriers. I think you have already known about the minority carriers and majority carriers, but I am giving you an example of this. Suppose we have a diode like this. This is a NP diode. There must be a potential barrier inside this. If we are going to connect a negative potential at here and a positive potential over here, so the electron will repulse the electron inside this material to cross this barrier, and the positron will repel the positive charges holes to this sides, and after some time this will cross this barrier. So there is the flow of electron from here to here. If I am going to connect a positive here and a negative here, so the electron and the positron will attract each other and the potential barrier will increase, and hence, so in this case a minor current will flow, that is called the minority carriers. So this is the concept of majority carriers and minority carriers. Junction means there must be a junction in their transistor. Junction are two junctions. Transistor means transfer of resistance. So about the BJT bipolar junction transistor, so this is the circuit, this is the diagram of the bipolar junction transistor. This is the base. Suppose I am taking NPN transistor. This will be the base. This must be the emitter, and this is the collector. So the base is tiny with respect to both of them and is lightly doped. Lightly doped. And the emitter is slightly or moderately doped, means that it's doped in the ratio that is greater than the base material. And the collector, which collects electron from the circuit, this is heavily doped, means the ratio of the electron or holes in this material is greater than the other two, and this is wider in the area, or this has more surface area, because this region collects electron and the heat will produce at this point, so there is the fear of damage to the device. So that's why the area of this material is greater than the other two to dissipate the heat. Now we are going to talk about the region of operation. Region of operation. Region of operation. There are three well-known regions. The first region is region of operation means a device which work in a region. Like the transistor, we may operate the transistor in the active region. Active region. Second one, we may also operate this transistor in the saturation region. We may also operate this device in the cutoff region. Cutoff region. Now, in the active region, this region is used for amplification purpose. Amplification purpose. Suppose we are required to amplify a power, current or voltage. So this region is used there. And the other two regions are used for switching purpose. Switching purpose. In this region, we are switching a device, turn on, turn off. So these two amplification and switching are used on the basis of the circuit requirement. Now, how to obtain active region? For active region, we are going to make this base emitter junction. This base emitter junction. This is junction 1 and this is junction number 2. So we are going to make this base emitter junction as a forward bias. Base emitter junction. Forward bias. Biased. And the second one, we have to make this base and collector junction as reverse bias. Base collector junction and the base collector junction as reverse bias. Reverse bias. And to obtain the saturation region or to work in the saturation region, we need to make this base emitter junction as well as base collector junction as forward bias. Forward biased. And for the region to work in the cutoff region, we need to make this base emitter and base collector junction as reverse bias. Both junction we are required to make this reverse bias. Reverse biased. Now there are some configurations. The first configuration is emitter, common emitter configuration. In this case, the emitter is common between the base and collector junction. Emitter is common between base and collector. The second one is common collector configuration. In this case, the collector is common between the emitter and base. And the third one is common base configuration. Common base configurations. It's need to be mentioned that these all things are just to remind the previous work, just to clear that you have covered the BJT. Now the common emitter configuration is used to obtain are used to amplify power, and the common collector configuration is used to obtain amplify current, and the common base configuration is used to amplify voltage. Now symbol used for NPN and PNP transistor. So the first point to note for the symbol or for the representation of the symbol is that the arrow in the symbol will always point from P to N. From P to, suppose someone has given you a symbol like this and you are asked whether this is a NPN transistor or PNP transistor, and the arrow is pointing from here to here. This is the base, this is the emitter, and this is collector. So the arrow is pointing from here to here. So I have mentioned above that the arrow will also always point from P to N. So this is my P point, this is N point, this is always P point. So this is PNP transistor. Now for the other one symbol, this must be opposite to that one. So this is the symbol. Now in this case the arrow is pointing from here to here. This is base, this is emitter, and this is collector. So this is my P, this is N, this is N. So this is NPN transistor. So I hope you guys have get the overview of the BJT. If you have any query, so you can ask in the comment section. Thank you.